Hello all, welcome to the video lecture. In this video, we'll be discussing about the HBase. In our previous video, we discussed about the shortcoming of Hadoop or Hadoop Distributed File System (HDFS). In HDFS, we can perform only the batch processing, or the HDFS can only perform batch processing and data can be accessed in the sequential manner only. So in order to perform some kind of random read and write operations, the SDFS does not provide that kind of facility. So so the SDFS is used in order to perform this kind of random read and write operations. So here is the introduction of HBase. This HBase is a database management system that is designed to provide the quick random access to huge amounts of structured and semi-structured data. As we discussed, like the SDFS doesn't provide this kind of operations, so HBase is used, and it is a distributed column-oriented database built on the Hadoop file system, and it enables real-time analysis of data, and it can store huge amounts of data in tabular format for extremely fast read and write operations. So as it stores the data in tabular format, we can perform some read and write operations in very fast speed, and HBase is required in the scenario that requires regular and consistent inserting and overwriting of data even in the HDFS environment. So when we have to keep on writing, like if there are lots of read and inserting and overwriting and accessing of data, so it can be useful in this kind of scenario when we are in the Hadoop environment. So as it's a part of the Hadoop ecosystem, it provides random and real-time read and write access to the data in the Hadoop file system, and one can store the data in HDFS either directly or through the HBase. Like as we discussed in our previous classes, we can store how we can store the data in HDFS. Like if I'm a data producer, so we can see here we have got the here is data producer. This producer can write, or this he can save the data in HDFS either directly, or he can go through HBase, and then he can read or write. He can read or the HBase can read or write, perform on the HDFS, and when it comes to the data consumer, he can read the HDFS through the HBase. And HDFS sits on the top of the Hadoop file system and provides the read and write access. As we can see here, like here is HDFS and it's on the top of HDFS, and it can perform this read and write access, and data consumer and data producer can write, or the data producer can write on HDFS through HBase, and data consumer can read the data through HDFS. So let us see the storage mechanism in HBase, or how data is stored in HBase. Basically, there are two types of data storage. There are two types of data storage. We can store the data in two ways. One is the row oriented, and the one is the column oriented. We can see here, like in the figure, the in row oriented database, it's a traditional database like Oracle, MySQL, and so on, and it stores data table by row and column method by storing the table. Like the method of storing a table is to serialize each row of the each row of the data, like we can access data through the each row of the data, or uh, like the rows stored sequentially in a file. We can see here the row, the each row signifies the some kind, it signifies the our data. And uh, whereas um, then the second is like another type of the uh, storing mechanism is column oriented. In column oriented, uh, all the columns values are stored together. Like the first column values will be stored, like the first column we can see here, like the just it is just reverse of mm, row oriented. In column oriented, what it does is like each column, here what happens is uh, like the first column value will be stored together. We can see here, like here key is stored together, then second is stored together, and then third one is stored together, and in this way all the columns are stored together. So it is used when the amount of data is very huge, like it's in the petabytes or in exabytes, and the data of single column is stored together and it can be accessed faster. And in row oriented approach, is like the row oriented approach comparatively handles less number of rows and columns efficiently, as a row and database stores data is a structured format. When we need to process and analyze the large set of semi-structured or unstructured data, we use column oriented approach. And such as applications dealing with the online analytical processing, like data mining, data warehousing, and applications including analytics, and so on. And the online transaction processing, such as banking and finance domains, this kind of this kind of this kind of task um, requires like uh, uh, they require some kind of transactional properties, and they use just a row oriented approach. So row oriented approach is used in online transactional processing, whereas some kind of analytical processing, for the online analytical processing we use column oriented um, column oriented tables or column oriented database. So HBase basically is a column oriented database, uh, and the data is stored in table. We can see here, like even though it's a column oriented, but the data is stored in the table. We can see here in the example. And the data model in HBase is designed to accommodate semi-structured data that could vary in field size, data type, and columns. And additionally, the layout of data model makes it easier to partition the data and the distribute it across the cluster. So it is the data model is designed in such way that we can cluster it based on our, this table can be clustered based on the requirement. And the data model in HBase is made up of different logical components such as tables. We can see, like such as tables, rows, column families. We can see here column families, like here for simple example we can see here some column families, and columns, like we can see here columns, and cells, and the person. So we will see here, we can see here another example of the storage mechanism in HBase. Like we can see here, it consists of a table, but in this table we can see some kind of different components, including row key, like the column family, column qualifier, and cell. We will discuss about this one by one. Like the table, this table are the more like logical connection of rows stored in separate partitions called regions. As shown above, like every region in is then served by the exactly region server. Like we will discuss about these region servers, but region server and these regions in coming, like it consists of the table, and like here in the row is an instance of data in the table, and it is identified by the row key. We can see here for some instance of data, we can see here row key. Like for each row, it will have a some kind of row key, which is uh, and these row keys are unique in table and are always treated as a byte. And we can see here column family. We can see here like column family. And this column family, uh, like the data in row are grouped together as a column families, and each column family has one more columns, and these one or more columns, and these columns in the family are stored together in the low level storage file known as S files. We can see here, like we can see here column two column families. Like we can see even here, like the we can customer, one is customer column family, and another one is this sales column family. Here customer column family and products column family. And column families form a basic unit of physical storage to which certain as features like compressions are applied, and hence it's important that proper care to be taken when designing a column families in the table. So columns, like column family is made up of one or more columns. We can see here, like each column family, uh, this column family is made up of one or more columns. Here in our example, it consists of both of the column family consists of two columns, and a column family is identified by the column qualifier that consists of column family name concatenated with the column name using the column. For example, we can see here example column family and the column name. You can see here, like and there can be multiple columns within the column family, and rows within the table can have varied number of columns. And column qualifiers, each column's name is known as the column as its column qualifier. We can see here, like this is the column name is identified by the column qualifiers. And cell, like this, a cell stores the data and is essentially a unique combination of row key, column family, and the column qualifier. And the data is stored in a cell, and it's called the value, and data type is always treated as a byte. We can see here. And the version, another thing here, here the version, the data stored in cell is versionized, versioned, and versions of the data are identified by the timestamp. The number of versions of the data retained in column family is configurable, and that is value, the value by default is 3. Like initially it's set to 3, but it is configurable. And column oriented, let's see like the difference. In row oriented database, it's suitable for, as we have discussed before, it's suitable for online transaction processing OLTP. And for column oriented, it is suitable for the online analytical processing. And this kind of row oriented databases are designed for a small number of rows and columns, whereas column oriented databases are designed for use tables. And let's see some kind of features of HBase. The HBase is linearly scalable, which means when we add more server, it should increase the performance and the capacity, like the performance and capacity in terms of storage capacity and processing power and input and output operations. This means the like the relationship of the capacity and the uh, like the performance and the number of added servers should be linear. That should be linear, like as we add the servers, it should give the relationship, like it should they should the performance and the capacity should increase linearly on adding the server. So another so HBase is linearly scalable. This means as we add the number of servers, like it is, we can call it the uh, horizontally scaling. And as we increase the number of server, the performance also increase with vertically. And it is automatic failure support, like as it works on the Hadoop environment, like uh, so it when there is a failure in one cluster, then it is some kind of it supports in such kind of scenarios. And it provides consistent read and writes, and it integrates with the Hadoop, both as a source and destination. And it has easy Java API for the client, and it provides data replication across the cluster. So as the data replications across the cluster is available, so in case of automatic failure, it supports while the automatic failure occurs. So where to use HBase? Basically, this Apache HBase is used to have a random real-time read and write access of big data, and it hosts very large tables on the top of cluster of the commodity hardware. So it is non relational data model after data base modeled after the Google's big table. And this big table uh, acts upon like big table acts upon the Google file system. Likewise, Apache HBase also works upon the top of Hadoop and HDFS. That means we can read or write the file of HDFS using the HBase. And application of HBase, it's used whenever there is a need to write heavy applications. And it is used whenever we need to provide fast random access to the available data. And companies such as Facebook, Twitter, Yahoo, and Adobe uses the HBase internally. Facebook was using this HDFS till 2018, basically to store the messenger. Like for messenger, the the Facebook was using the HBase. Now it has shifted to another uh, database management system, but previously until 2018 Facebook was using HBase. And let's see some components of the HBase. And HBase has basically three major components, which are HMaster and HBase Region Server and the Zookeeper. This HBase physical architecture consists of servers, like we can see here the servers in a server master and slave relationship as shown here. Like we can see the master server and slave server, and this as master and the region are are configured in as a master server and slave server. Typically, this HBase cluster has one master node called HMaster and multiple region servers as a edge region server. We can see here in the figure, and each region server contains multiple regions which we call the edge regions. And just like a relational database, data in HBase is stored in tables, and these tables are stored in the regions. We can see like these tables are stored in the region server or regions. And when table become too large, then this table is partitioned into the multiple regions. Then when we have when the table gets larger, then these are partitioned in the multiple regions, and these regions are assigned to the region servers across the cluster, and each region server hosts roughly the same number of region. So we can see as master, and basically this which reside it basically the edge master, it resides on the data node. And let's see how this edge master handles the collection of region server and which are in the data node. Like we can see here, edge master handle the collection of region server, and these region servers are in the data node. And let us see how it handles the these regions. Like these edge masters perform DDL, this data definition language operations, like create and delete tables, and it also assigns the regions to the region server, which we can see in our image, in this image. And it coordinates and manages the region server similarly as a name node manages the data node in HDFS, and it assigns regions to the region server on the startup and reassigns the regions to the region servers during the recovery and load balancing. And it monitors all the region servers instances in cluster with the help of Zookeeper, and performs recovery activities whenever any region server is down. So another component is the region, and this region contains all the rows between the start key and end key assigned to that region. And these HBase tables can be divided into the number of regions in such a way that all columns of the column family is stored in the one region, and each region contains the rows and sorted in a sorted order. And many regions are assigned to a region server which is responsible for handling, managing, executing reads and writes operations on the set of regions. And we can see here, like in simple language, we can see like a table can be divided into the number of regions, and a region is sorted. A region is a sorted range of row storing data between a start key and the end key. And a region has default size of 256 megabyte, which can be configured according to the need. Like it is the default size 256, and a group of regions is served to clients by the region server, and a region server can serve approximately 1000 regions to the client. So another important component of the HBase architecture is the Zookeeper. It acts like a coordinator inside the HBase distributed environment. Basically, it helps to in maintaining the server state inside the cluster by communicating through the sessions. Like every region server along with the edge master server sends continuous heartbeat at the regular interval to the Zookeeper, and it checks whether the server is alive and available, like as in our like in which is mentioned in our above image. And it also provides server failure notifications so that recovery measures can be executed. And referring from the above image, we can see that there is an interactive server which acts as a backup for the active server, and if active server fails, and it comes to the rescue. You can see here some kind of inactive server. When this active server or active master fails, then it comes in the operation. And while if a reason server fails to send a heartbeat, the session is expired and all the listeners are notified about it. Then as master performs suitable recovery actions, when which we like and zookeeper is also responsible for maintaining the uh, the meta files path, which helps any client in searching for any reason. And this is all for the HBase. And for uh, and for more, we'll be discussing in our next class. We'll be discussing basics of hab and pix, and then we will go for the big data analytics algorithms.